Hello and welcome. Today, we're diving deep into the monumental challenge and exciting prospect of establishing a sustainable human presence on the moon. It's not science fiction anymore. It's a goal actively being pursued with innovative solutions. First up, where will astronauts live? Initially, pressurized landers and rovers will serve as temporary homes. But the Artemis program and international partners are looking at aluminum cylinder-like modules, similar to sections of the International Space Station, about 10 meters long, as early surface habitats. A huge part of making this viable is in situ resource utilization, or ISRU. That means using local lunar materials. NASA's Moon to Mars Planetary Autonomous Construction Technology project is exploring robotic 3D printing using lunar regolith mixed with binders like water, potentially extracted right there on the moon, to build habitats and landing pads. Chinese researchers have even made lunar bricks from simulated lunar soil, reportedly stronger than standard ones. Some innovative concepts propose melting lunar glass compounds to create large spherical shell structures. And inflatable habitat technology is also being considered to expand living space efficiently. Beyond building materials, ISRU is crucial for essentials like water, oxygen, and fuel. The moon has water ice, particularly near the poles. This can be broken down into hydrogen and oxygen for life support and rocket propellant, essentially establishing a lunar economy. Other lunar resources like helium-3 are being eyed for future nuclear fusion reactors. Research is ongoing into extraction techniques like electrolysis and pyrolysis, with molten regolith electrolysis showing promise for decomposing molten lunar soil into metal and oxygen. Of course, keeping humans alive means robust life support systems, recycling air and water, much like on the International Space Station. But the moon is harsh. Extreme temperatures swing from 150 degrees Celsius at lunar noon to minus 180 degrees Celsius at night, and even colder in permanently shadowed regions. Then there's cosmic radiation and micrometeorite impacts. Radiation shielding is a major concern. Early Artemis missions will be limited in duration partly due to this. Strategies include burying habitats under lunar regolith or developing advanced shielding materials. And we can't forget lunar dust. This fine, abrasive dust clings to everything, posing health risks like respiratory issues and damaging mechanical systems. Airlocks with dust removal systems will be essential to prevent dust from entering habitats. NASA is actively testing dust mitigation technologies. Powering all this is fundamental. Efficient solar power systems are a primary focus, but the long lunar nights, lasting about 14 Earth days in most locations, necessitate energy storage solutions or alternative power sources. Nuclear fission power systems are being considered to provide consistent energy. Some concepts even involve space-based solar power stations beaming energy to the lunar surface. So what's the timeline? NASA's Artemis program aims to return humans to the moon and establish a long-term presence. Artemis 2, the first crewed mission around the moon in this new era, is targeted for September 2025. Artemis 3, planned to land astronauts near the lunar South Pole, is scheduled for September 2026. And Artemis 4, the first mission to the Gateway Lunar Space Station, remains on track for 2028. These timelines have been adjusted to allow for thorough testing. This isn't a solo endeavor. International collaboration is a key aspect. For instance, the Italian Space Agency is developing a surface habitat module. China is also actively pursuing lunar exploration, with plans for an international lunar research station. Numerous academic and commercial partnerships are driving innovation. The journey to establishing a sustainable human presence on the moon is an incremental process. Initial missions will rely on landers for habitat, gradually transitioning to more permanent structures. The development of technologies for lunar habitation also serves as a crucial stepping stone for future human missions to Mars, with the moon acting as a proving ground. Ongoing research, technological advancements, and international cooperation are essential for realizing the vision of humans living and working on the moon. That's all for today. Thanks for listening.